Possibly the funniest thing to ever happen on the internet was when Coco the sign language gorilla was exposed to be a fraud on an AOL live chat. So what most people know about Coco is that she was a gorilla who learned sign language so she could communicate with her trainers. But when in the early days of the internet, AOL hosted a live chat with her, we learned that she was obsessed with nipples. I will read you some of the highlights. The chat opens with the host asking Coco, "Do you like to chat with other people?" To which she responds, "Fine, nipple." Later they ask, "How do you feel about Michael, a male gorilla?" To which Coco responds, "Foot, foot, good." Her trainer says, "Foot means male, right?" And Coco says, "Nipple." Here is the best one. So the host just wants to know how Coco feels about the humans that raised her. Coco says, "Lips, apple, give me." The trainer says, "People give her her favorite food." But Coco says, No. Love, browse, drink, nipple." The trainer says, "Browse is like the little food and snacks we give them." But Coco doubles down and says, "Coco loves that nipple drink. Go."
You know what I mean, you know what I need. We play games of love to avoid the depression. We've been here before and I won't be a victim. Why you always in the mood? Fuck around like I'm brand new.
Weird body fact or cool thing that your body can do.
Oh, I got one. It's definitely not cool, but it is weird. So I was born with an incredibly rare genetic mutation called Klippel-Feil syndrome. To grossly oversimplify it, you're supposed to be born with 33 vertebrae, but people with Klippel-Feil have at least 2 of the vertebrae somewhere in their spine fused together. I personally was only born with 31 vertebrae because I have one of the most severe versions of the condition because I was born with the first 3 vertebrae in my neck all fused together into one bone. You might be looking at my neck and thinking, it doesn't look like you have a spinal deformity. And you would be like every doctor I've ever visited for the first time because they never believed me until I showed them the x-rays I got when I was like 5. And you might be thinking to yourself, why would a doctor doubt you if you say you have an incredibly rare genetic mutation? And that's because you know somebody with Klippel-Feil syndrome. Me and Big Ed have the same exact genetic mutation.
This next part is just going to be me comparing myself to objects to prove that I'm tall. Kent High Haven, I need your help.
I decided to calculate his height using the most intricate method in my arsenal. With this photo of him wearing a narwhal onesie, I was able to apply Jonas Whitman's subtraction symbol. First, I needed a reference for the horn size, and whoever told y'all this was a narwhal horn lied. The horn had a height of about 5 inches, so we can subtract the height of the horn from the height of the door to be left with 75 inches, minus about 1.5 inches for his hair, for 6'1½". However, that was kind of boring, so I decided to calculate his shoe size, comparing some of his sandals to my dad's, which should be around 4.5 to 5 inches in width, which leads me to believe his flooring does have an 8-inch width. So I duplicated his foot and turned it, which allowed me to gauge that it was about 1.5 planks. The only negative factor being if they had mixed widths. So I multiplied 12 by 2.54 to convert to centimeters. I'm going to say you're size 12 in Vans because I saw you wearing some of these, and probably a 12.5, 13 in Nikes. Let me know if I'm right.
Happy on the asset social, man. Loyalty over royalty, y'all niggas know the vibes. Fuck your Achilles beat.
Whoop it, bitch, I'm my
Plant! Finger a seed into some dirt! Now it's a whole new thing! Next lesson! That Beatus man's coming to get you and there's nothing you can do about it! Next lesson! Coffee! Use it to replace motivation! I'm f***ing happy! One!
Are cats built different, or was this a fluke? Let's dive in. So there's 2 main forces, the force of gravity and the force of drag. I ignored drag in my last video with the trampoline dude, but in this case it actually plays a big factor. So Newton's second law, the sum of forces is mass times acceleration, the force of gravity minus the force of drag because drag is opposing it. The force of gravity is the mass m times the acceleration due to gravity g. And the force of drag is a bit more complicated. We'll talk about each term in a sec. The first term, the force of gravity, is a constant, but the second term is a function of velocity. Let's plot each of these forces separately to get a better conceptual understanding of what's going on. So the force of gravity is a constant, so it's a horizontal line, and no matter what velocity the cat's going, it's always the same. The drag force looks like a parabola though. I'm bad at drawing parabolas, but this is your typical y equals x squared, except y is f and x is v. The sum of forces, or the net force acting on the cat, can also be shown graphically by subtracting these two visually. So we take our constant gravitational force and subtract the drag force. Do this for each velocity as the cat's falling, and you can get a graph of the net force that looks like this. Now mathematically it can go below this line, but in reality it can't. This velocity is called the terminal velocity. The net force is 0 at this point as shown on the graph, so there's no reason the cat's velocity would change, which is the acceleration. All this is just to show that there is a maximum velocity or a terminal velocity the cat will reach no matter what height it's dropped from. With acceleration equal to 0, we can now solve for this v. I'll skip forward a little bit since this is just algebraic stuff. Now we need to plug in all the values. So we got the square root of 2 times, let's say a normal sized cat, 4.5 kilograms. Acceleration due to gravity is 9.81 meters per second squared. This density is for the fluid, which in our case is air, at 1.225 kilograms per meter cubed. I never explained it before, but CD is the drag coefficient. It depends on the geometry of the falling object. I couldn't find any resources online for the drag coefficient of a cat that looks something like this, so I'm just going to assume it's close enough to a box. Obviously these assumptions will affect my final answer, but I doubt there's any cats that are watching in dire need of accurate answers. Another assumption I'm going to make is that the cat's roughly a foot-long Subway sandwich, or 30 centimeters. And based off this cat door I found online, it's about 18 centimeters wide. I didn't need these dimensions to calculate the drag coefficient, which is just a lookup value on a table, but since I already drew this, I figured it's a perfect time to calculate A, which is the cross-sectional area. So that value is around 0.054 meters squared. And I just used this random resource online to find that the drag coefficient for a box is around 2.1. Now I've got all the values, and before I crunch the numbers, I want to check to make sure the units check out. I've got the square root of meters squared over seconds squared, which comes out to meters per second, which is a velocity, so I'm good to go. After putting it in my calculator, it's about 55 miles per hour, which is cool because that means no matter how high you drop them from, they can't fall any faster. I also think it's a cool fact to know that there's a 90% survival rate when cats fall from 5.5 stories or higher. Don't ask how I know.
Hey, do you think aliens exist in the universe? If you do, then do you also think that there are alien civilizations out there that are way more advanced than us? If you also think so, then think about this. Have you ever watched the David Attenborough's documentary? We can see the animals so close and so clear because the camera is just right there, but the animals are not even aware of it. Because we are more intelligent and we have better technologies. So it's possible that there are a lot of alien cameras pointing at us right now that we're not even aware of, broadcasting our daily lives back to their home planet. And the aliens who are watching it love it.
Hey guys, I'm going to use this giant lens to make lava out of this volcanic rock. Watch this. Heat from the lens has turned the surface of the rock into a pool of lava, and it continues to melt the rock. I'm going to take the light off so you can see what it's done. You can see the lava is now cooling and it's turning into a pool of obsidian.